Please welcome our panel, Mastering Anomaly Detection and Test Case Generation in ML, with Anshuman Patnaik from Embark Trucks, Eric Chu from Zoox, and moderated by Chris Barker from CBC Transportation Consulting.
Hi, Eric and Anshuman, welcome. It's good to have you today, and we're discussing anomaly detection in autonomous mobility. And as we dive into this subject, I'd love to get your thoughts on how you describe what an anomaly is in autonomous mobility from both of your perspectives. And Eric, I'll start with you.
Yeah, sure. So the way I think of an anomaly, I take a more statistical approach to it. So essentially, we look at the distributions of other agents or ourselves, how we drive, what our driving performance looks like, and anything that's out of the ordinary, out of the expected statistical distribution, we consider that to be an anomaly. And of course, you can kind of pick thresholds. You can say if it's in the 95th percentile, 99th percentile, things like that. But we try to quantify how anomalous or how surprising the specific observation is.
Yeah, and I would have to agree with sort of Eric's take here on what anomaly means, even for Embark Trucks, where we kind of drive specifically on the freeway. I think you can take a very similar approach to what are some of the weird things or some of the things that you see once every 10,000 or 20,000 miles, and how those specific events actually change the way that the system behaves or should behave in those cases.
So when you think of anomalies in autonomous mobility, it could be something like a traffic cone or a series of traffic cones appearing in a pre-mapped roadway, or someone walking down the sidewalk, perhaps in costume, or things that are out of the norm. I'm curious, from all the data that you've captured, what are some of the most unique anomalies that you've come across as part of your testing and planning activity?
Yeah, so because Zoox operates in the city and in urban environments, we see a lot of very, anomalous driving. Or another way to describe it is just surprising driving. So sometimes what we see when we're in the city is we see people missing their turns or about to miss their turns, and they'll cut across several lanes of traffic. And so our system has to be able to understand that and handle that and react in a safe way. And those are kinds of things that worry us, if you will.
And how do you, Eric, that's a great point. How do you adapt to that unexpected behavioral situation? How do you build that into your testing activity?
Yeah, so essentially what we do is we have our what we call our L3 fleet. Those are our retrofitted vehicles, and we have safety drivers in them. And so they go, we drive around the city with the safety drivers specifically to observe and collect this kind of data to find these anomalies. And then what we do is we create these what we call structured testing. So we try to replicate them as much as possible in both simulation and in controlled real world environments. And then we vet the stack against those kinds of situations.
And Anshuman, on the trucking side, what kind of anomalies are you seeing popping up?
Yeah, I think similar to sort of Eric's statement of, hey, an actor or an agent not reacting to maybe the specified rules of the road. I've seen things, people driving 65, 75 miles an hour on the shoulder. That's not really expected behavior. And then that can obviously cause interesting interactions. I think we've all been there of, hey, there's an exit coming up. Oops, haven't seen it. I'm on the leftmost lane. Let me cut aggressively across in potentially unsafe behavior and try to make the exit when in reality you should be going to the next one. So I think we see a lot of situations like that, but also I think there's a lot of interesting objects that can end up showing up on the freeway, whether it be loose garbage bags, debris on the road, blown out tires from other trucks. All of those sort of obstacles present different sort of environments and scenarios for the truck to react to.
And so when you see an object on the road, whether it be garbage or some larger object, how are you adapting your systems to be able to handle that safely and continue the navigation of those trucks safely down the freeway?
Yeah, and I think the most important thing, and I'm going to echo off sort of Eric's point here, is that you have to be laser focused on creating metrics and systems that actually reference and actually characterize the model performance against those specific scenarios. By the very definition of what anomalies are, if we take a very traditional approach of here's an aggregated metric that shows performance across a large data set, it's not going to help you out in actually targeting these scenarios. So fundamentally, when we see those objects, we think of it as, hey, there's got to be a change in the process if we already do not have systems and metrics capturing those specific events. And then once we actually set up the systems and metrics to capture and characterize those events, then it's a matter of iteration and having sort of focused energy to actually solving those specific problems instead of trying to solve the whole pie at the exact same time.
So to that example, how, if you detect an object in the road, how is that data captured and then shared within your operation, or perhaps even within the city or broader operating environment, from a safety point of view and a navigation point of view?
So I think when we come through sort of complicated scenarios, specifically within Embark and the deep learning team, it's something that is expected to be shared, especially the anomalous behavior, primarily because we are a multimodal stack. So what that means is we have various different kind of sensors that get to see the same object in slightly different lenses of views. As a result, generally speaking, an anomaly in one sensor would not necessarily be an anomaly in the other sensor, but it might. As a result, we believe in this collaborative effort of like, hey, here's a set of interesting scenarios, and we should test individual model performances against those interesting scenarios. And that's more from like an engineering perspective. From an operational perspective, I think especially, I think we operate in a very similar manner to Zoox today, where we have a safety driver behind the wheel, and we make the drivers and operational engineers aware of these situations of, hey, this is where our system is today, this is where the system needs to be tomorrow, and this is how we are thinking about handling these sort of situations. And I think one thing that we can leverage here is, we rely on the safety drivers to tell us how would a human react? Because that's what inevitably that's what our system should try and mimic, or at the very least be better than in those situations.
Yeah, 100%. Just kind of riffing off of that, the safety drivers do give us a lot of data about how humans respond to these anomalies. And so what you actually get really good, decent training data to look at it and say, oh, does our system respond the same way? Do we perceive, do we see that tire in the middle of the road? Do we see that trash bag? Are we swerving? Are we overreacting to it? Or are we reacting the same way that the safety driver does? So yeah, the safety drivers give us a lot of information about how to react robustly to these anomalies.
From both of your perspectives, do you feel the anomalies that you're detecting, is that limiting what's possible in deployments of autonomous vehicles, or is it enhancing, or how would you describe the role that anomalies are playing in going to a bigger scale potentially of these types of operations?
Anshuman, do you want to take us out?
Yeah, sure. I can kick us off for this one. So I think before I actually answer this in the context of AV, maybe I can take a step back. And I think for practitioners in machine learning and deep learning field, tails become the bane of our existence. It is one of the hardest things to solve in this place. And then when we're talking about anomalies, in my opinion, those are the tails of the tail. So you're literally talking about events that you have very limited examples of. And so that itself is a challenging problem. When it comes to actually AV, in my opinion, there's one level of complexity that gets introduced, because when we're operating, you have to take into account two things. One, we must identify that we're in an anomalous setting, but then more importantly, you have to be able to react safely. When you come up to these anomalous situations, even as a human driver, sometimes those are the panic moments of like, oh my God, this is not something that I went to driving school for. How do I react to this situation? And in a similar sense, the AV system might be in an anomalous state, but it still needs to make the appropriate and safe decisions. And I think that's one of the challenges when we talk about anomalies, and specifically in the space of AV, because it's not just about identification, but it's also about having appropriate reaction. And you can imagine a truck driving 65 miles an hour down a freeway. You have to be able to react safely and make the appropriate maneuvers to make sure that, if you're unsure, still maintain the high levels of safety that we hold ourselves to.
Yeah, I second that. It's really about how do you respond. So number one, how does the AI identify that's an anomalous state? The best thing is if the AI can handle the anomalous situation, like a human would. But the second best thing would be, hey, I'm in an anomalous state. Let me react appropriately, either slow down, pull over, swerve, something, but also phone home, right? So we have at least for Zoox, we have the ability to remotely guide the vehicle. So what we could do is the vehicle could say, hey, something weird is happening down the street. I see a construction zone I haven't seen before. Let me slow down, and then let me call home, and then ask for some human guidance through this situation. So there's little things that we can put in place. I don't think all the anomalies are unique. But I think the anomalies can be categorized into some of these, we can have remote guidance, remote operators help us through it. Some of these we need some new thought around how to approach it, and so on and so forth. But it's exactly that. It's how do you know when you're in an anomalous situation, and how do you respond appropriately to it? And generally, if you think about humans, you have two things that you can do. You can either slow down, you can speed up. I guess slow down, speed up is the accelerator, or you can swerve, so you can go left or right, or you can slow down, speed up. And those are the controls that humans have, and we're very good at handling anomalies. So the next step for us is collecting that information, understanding what the different taxonomies are, and then devising engineering systems to handle each of those situations.
And Eric, to your comment, how would you assess how the anomalies are advancing the machine learning side of things, and the cars and their operations more and more sophisticated and more adept to deal with these different unexpected scenarios? How's our progress in that area, in your opinion?
Yeah, so I wouldn't be able to tell you how our progress is, but I can tell you how we would approach that, right?
Sure.
So obviously for Zoox, safety is foundational. And one of the most important things for us is when there's an anomaly, we record it. It's stored somewhere. It's a database of these anomalous events, and then we can reproduce them. So we can either rerun it in simulation, see how we would do, and continue to maintain a track record of maybe like last week we had 800 anomalous events. This week we have 700, but of the growing data set, like we're starting to be able to handle more and more and more. So it's really about keeping ourselves accountable and tracking those events, and then making sure that we're knocking them off one by one, or we're building systems to knock off like big chunks of them. And then the other thing, of course, is whenever you release a new version of the software, you want to run it against that same bank and make sure that you aren't regressing against it. So, the flat tire in the middle of the street, maybe we handled it 2 years ago. Ideally, what's happening now is we're not discovering that, hey, that test case that we could handle before, we've regressed on it. So really, it's about keeping a catalog of these anomalies and making sure we're addressing them and continue to address them one by one.
Yeah, and I think I couldn't echo that point anymore. I think we take a very similar approach here at Embark in terms of when you're building out your test sets. Like I mentioned before, it's very important to kind of have the stratifications required to actually categorize these anomalies. I think it's important for us to not fixate on a single particular event and have that be the North Star for our system. But I do agree with Eric here that there is categories and patterns of anomalies, and not only from a detection and perception standpoint, but also from a planning standpoint, where we as a truck would react to those in a similar manner. And it's super important that when we sort of keep developing these models, you don't improve in one anomaly and then accidentally regress in the other. So it's very important to kind of keep those benchmarks and keep ourselves and our systems honest towards what do we actually need to do on the road. So fundamentally, it's super important to keep that connection between this is what we're testing and then this is what's actually happening on the road in terms of driving our philosophy forward for our models today.
Shuman, to that point, do you have any concerns about bias in your training data and how you make things a bit equal across the landscape?
Yeah, and I think, at least to me, in the context of this conversation, I think you're actually asking two sides of the same coin here. Fundamentally, for me, if we're strategically and improving our edge cases, by the very definition of what we're doing there, we should be systematically reducing the bias that exists in our systems. So for my interpretation of your question here, it's, hey, we've seen this many scenarios, and you have the average case or normal case potentially being overrepresented. So if we're actively working towards the edge cases and adding these edge cases into our system, by the very definition of what we're doing, we're reducing the actual bias that exists in our system for these for these overrepresented cases. So I do believe it's a challenge, but I think solving the edge cases actually help you reduce your bias in a similar manner at the same time.
And do you have the same thought on that, Eric?
Yeah, no, 100%. It's the same thing. Like, when you're part of the challenges of machine learning is like your training data, you only generalize so far as what you see in your training data. And so the more you can discover in the tail, the better your models will be and the more robust they'll be. So whenever we see an anomaly, it's somewhat of an exciting thing, right? It's great. We have another data point that we can learn from, and we can have the model be more robust in the future. So, the edge cases are extremely valuable for us in terms of being able to collect those edge cases and get them from the field and then put them in our system.
So we're getting some questions from the audience. I wanted to field one. What have you seen as the most challenging type of edge cases that you've had to, or anomalies that you've had to try to solve for so far in your application testing? And Eric, do you want to take that one first?
Yeah, I think the most challenging one. So remember how I said there's a taxonomy of different kinds of anomalies. So the most obvious thing to do, that happens is, hey, I see something coming. I see something down the line, and I need to take reaction. So maybe I'll come to a stop. Sometimes the most challenging ones are when that reaction is not a stop, but maybe like a reverse. And so then that we've seen some of those cases in San Francisco where, there's some hills and things, and there's some cars coming down the wrong way, and you're like, oh, I gotta back up. And that's much more challenging from I think from a planning standpoint, right? Your motion planner, you get to reverse the motion planner, all of that stuff. So those have been, thinking through the taxonomy of edge cases, the most common ones are ones where you need to come to a stop. But there's other cases where maybe you need to speed up. And then there's still more, in the taxonomy, if you think about the edge cases in the taxonomies, and somewhere near the bottom is like, oh, maybe we need to go into reverse. And that, that can be very challenging. So we've seen that before.
What about as cities are removing traffic lights and replacing them with roundabouts? And you're dealing with these vehicles coming in from multiple entry points into a roundabout. How are you approaching things like that collectively?
Yeah, in terms of roundabouts, that's a planning problem. That's a pretty well-known, stress test of the motion planning stack. Mm-hmm. That's less worrisome because it's not really an edge case, right? That's kind of like, we have a roundabout. We've got lots of roundabouts. We'll use London as an example. We've got lots of roundabouts in London. You just have to learn to navigate those. And there's a lot of, the difficulty is navigating, there's some of the car coming, yielding to them and so on, and figuring out the social aspect of it. But that's common. Maybe that's the right way to put it. It's like, we can go driving in the city, we can collect a lot of that data and we can figure that out. The edge case would be, if some car is stuck in the middle of a roundabout, it disrupts the flow. Even that's a little more straightforward than I think most people would think.
And Shuman, any severe challenges that you're seeing from your side?
Yeah, and I think edge case behavior in the context of freeways, I think it's super interesting to kind of analyze. I think a lot of sort of my focus, at least at Embark, has been challenging the assumptions of a structured road. I think that's probably the kind of edge cases that I've seen the most, and probably the most challenging are things that, when we are designing our taxonomies or rulebooks, we don't really think about because, technically speaking, a freeway is a structured road. But I think one of the things that I've seen, at least with some of the edge cases that we've seen, it's you constantly have to challenge that assumption. Just because the road is structured doesn't mean the actors on the road are going to be taking structured actions. And so I think those are some of the edge cases that we see specifically with, objects on the shoulder, reacting in interesting and different ways, or objects that don't necessarily set the appropriate distance when stopping on the shoulder and are peaking halfway into the lane. They're just challenging this assumption of like, just because you're in a structured road doesn't necessarily mean the actors on that road are following any sort of structured road.
Shuman, your question is a perfect segue to another audience question that's come in. Question from the audience is, when solving anomalies, is it always based on sensor data? Or is there a model that looks at geospatial and other location information for solving for these issues?
Yeah, maybe I can start there. So specifically, as we operate on, large chunks of road on the freeways, we cover quite a large distance. I think it's important to take into account geospatial data when it comes to data collection, because some of these events or some of these anomalies are going to be a function of where you are on the road. And I think one thing that we can take advantage of that prior is you might want to collect more data or just do more loops in that situation to increase the frequency of the anomaly that's actually showing up in your data set. So that's one way to take advantage of it. I think in the sort of when discussing the tail, I would also be careful of trying to incorporate geospatial data, because again, you're feeding in this prior that exists into the model. And like I mentioned before, one of the things that I've seen with the edge cases is that it's not necessarily a function of geospatial data, because an actor or an event might happen not as a function of geospatial data, but just as a function of the actor itself.
And Eric, your thoughts between Sensor
Yeah.
and geospatial.
So geospatial data, extremely valuable. I think for us, the context, it comes up in the context of construction zones, right? So, maybe there's one vehicle driving around the city and it's, you see the construction workers set up the construction zone. That's a really good signal that, hey, whenever we drive through this intersection, there will be a construction zone that we should consider, we should handle in that location. So location definitely matters. Time matters, right? The construction zone is not going to be there forever. So we shouldn't just put this, big flag in our database that says, hey, there's always going to be a construction zone here. We need to think about, how much time has elapsed since we had that information. But yeah, it's extremely important. It's an external prior that we can add to our inference engine, and we can make better decisions as a result of having that information.
Eric and 𝘁uman, this has been a great chat. We're out of time for today, but look forward to continuing the conversation. And thank you both for your time. And we'll look forward to seeing you for the next roundtable.